Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we will be looking at differential calculus. The two things that we're going to be looking at, we're going to look at the first principles and we're going to look at the rules. At the end of this lesson, each and every one of you must be able to do the following. So in other words, these are the objectives, the aims of this lesson for today. We must be able to work with functional notation. So if we are able to work with function notation, at the end of this lesson, then we'll be able to do some of the things that in calculus. We must be able to find the rate of change of two functions between 2 points. So I'm stressing the 2 points or the average gradient. So the average gradient between the 2 points, that is what we will need to also find that. Now calculate the derivative of the function from first principles. So we must be able to do first principles and we'll show you how. Then we must be able to determine the general rules of the differentiation. We must be able to also use the rules to calculate differentiation. Determine the gradient and the equation of the tangent to a function at a desired point. So in other words, a point will be given. We need to be able to do that. But first, let's talk to what differential calculus is. Now, calculus is nothing else, but it is a rate of change of a function. So in other words, when we talk about the rate of change, we'll be talking about the gradient, we're talking about the slope. So it is how much the gradient or the slope of a function will change. So that is what we are going to be doing. Now, the function notation, we've done this when you're doing the polynomials, but we're just quickly revising it. The notation f of x, it defines that function, and that function is named f. So this will read y is a function of x. That's how it reads. Now that letter x that you see there, it represents what we call the input. So when we're doing the functions, f of x, it's equals to maybe ax squared plus b, x plus c. So that f there, that x there is the one that we're going to substitute with. So it is the input or the independent value. Okay, so and the letter y, it's replaced by f of x. In other words, this thing here is nothing else but y. Okay, so we can write it as that bx plus c. And it represents the output. In other words, if I put a value in the value of x there, and then from there what I get is the output, which is going to be the value of y. Or we call it the dependent value because it depends on what you have put as an input on your function. Now let's look at the quick activities that we can do just to remind ourselves of what we are doing in polynomials, because in polynomials this is what we've been doing. Now look at this. We're given the function f of x, it's equals to minus 2x plus 1, which means that this will be our output, this one will be our input. So the x value there will be our input. So the input, we're saying the input must be 2 there. So in this equation means that whenever I see the value of x, the x there, I must substitute it by 2. So I'll have f of 2 will be equals to, so I'm no longer going to write negative 2x. What should I write? Negative 2 into 2, then plus 1. I must not forget that plus 1. Then from there, the output that I'm going to get will be negative 4 plus 1, and that will be negative 3. So we'll have that as our output. So the input was 2, the output now is negative 3. Right. Now, if I have f of a, what should I do with it? So same principle. So I'll have a negative 2, but in the space of x, what should I put? A. minus plus 1, sorry. Then the answer that I'm going to get there will be negative 2a plus 1. Can I add the 2? No. Reason? Unlike terms. Minus 2a plus 1 will remain minus 2a plus 1. So my final answer will be minus 2a plus 1. Right. Now the next one here, same function given. We need to evaluate that f of x plus h. Now look at this. The input now here, it's no longer x. It means that our input is x plus h, which means that wherever I see the value, the x there, I must substitute it by x plus h, because that x is no longer an x, it's x plus h. So which means that now I'm going to have, that will be equals to, so minus 2, where I see x, I put x plus h, then plus 1. Then I must then use the distributive method of multiplying negative 2 times x, negative 2 times h. Then the 1, it's outside the bracket, I cannot multiply that. So I'll have negative 2x, negative 2 times h will be negative 2h. Negative 2, it's done now. So now I'll have my plus 1, and there's nothing else that I can do to this one, so I'll leave it as that. So I'll put my answer as negative 2x, negative 2h, plus 1. Remember, the 1 does not have an x, so there's no way I can substitute on the 1. So the 1 is an independent value, it's a constant value there. Now let's look at this one also. Bit tricky. If I've got f of x plus h, I think I already have it there. So I already have it there, so my answer will be this one. But if I get this one as an independent question, what do? Same thing. So I'm going to say, where I see a x, I put x plus h. Then that will be plus 1. So this is for that one. So this whole thing there, it is for that. Now I have a negative here, which tells me that f of x, meaning that where I see x, I must put x. So obviously what I'm going to get there will be negative 2x plus 1. I've replaced the x by the x. Oh, well, that should remain the same. Right, but I must put it inside the bracket. Reason? I have a negative. Negative is my stop sign. I have that stop sign as a negative. Everything that is inside the bracket, all the signs that are inside the bracket after the negative sign will change. So now I'll have, work out what is inside the bracket there. I already know it's going to be negative 2x, negative 2h, plus 1. Then from there, negative and negative will give me a positive 2x. Negative times positive will give me a negative 1. So if I check, I want to simplify this now. How do I then simplify this? The negative 2x and the plus 2x will give me a 0. A plus 1 and a minus 1 will give me a 0. So what is left now? That is out. That one is out. What is left is negative 2h. So it means that if I've got f of x plus h minus f of x, that answer that I'm going to get is negative 2h. So the x's are gone there. Okay, right. And this is how we do when we have an output. When we have a function, we have an output, and then we need to get the, we have the input, we need to get the output. This is how we do it. Sometimes we might get an output and you are requested to get the input. So if I'm given f at x, I need to find the value of x, then I must be able to do it also. And I hope we have done that under polynomials. Right, now let's talk about average gradient between the 2 points that you have done also in grade 11. Now when we're working with the straight lines, remember when I'm working with a straight line, this is a straight line. I've got 3 points here that are indicated there. it is easy to determine the gradient of that graph by calculating the change in the x value between the 2 points and the change in the y value of that. So meaning that gradient will be the change in y over the change in x, not the other way around. And this, we stress it every year, colleagues, that we have that formula here, and that formula is there in the formula sheet. You get it every time, but we are still getting this formula wrong. We're still writing x2 minus x1 over y2 minus y1, and the formula is there in the formula sheet. So let's practice it. Let's practice it. I know you're done with analytical geometry, but this formula, you must know it. Right. Now, the gradient there, I said it remained constant, which means that gradient will remain constant throughout. So the gradient between these 2 points will be the same as the gradient between these 2 points. So which means that the gradient of the straight line will remain constant. It will always be the same number throughout. Now, let's look at the gradient of this one now, the average gradient between the 2 points. Now, if I've got a point here and a point there, you can see we have a curve here. So we have a curve there. So if I've got the two gradients, now look at this. This x value here, it's this one at the coordinates. Now that coordinate there, it's f at x for the y value. So we have the x value and the y value there. If from here I move h units to that point, then it means that I've added an h, right? So I'm just using letters here. So which means that this point here will be x plus h. Just to make an example, if that point here it's 2 and here it's 4, so it means that my h will be 2. So I've just added the 2. So now I'm working with the x plus h now. This point here will be x plus h. That point here will be x plus h. Will be x plus h, f of that, which is the y value. So if I'm working in with these 2 points, I need the gradient of that point. So how am I going to get the gradient of that? So if I need the gradient, so the gradient of that line, let's say the gradient of that line there. So I'm going to say the gradient will be equals to f of x plus h, right, minus f of x. Remember, it's the change in y over the change in x, minus f of x divided by, so let's look at this. So it will be the x value, it will be x plus h minus x, minus that x. So is the y2 minus y1 over x2 minus x1. So right now we're going to have f of x plus h minus f at x. I can't do anything with this, but my numerator, look at this, x minus x is 0. I'm left with h. So in other words, the gradient of a curve will be given by that formula. It will be f of x plus h minus f of x divided by h. Now, in this formula here, you can see we've already done that one. We've already done that one when we're substituting, okay? And the h there remains that number because it is the difference between that. So if I move this point closer and closer and closer and closer and closer and closer to that, so if I move this point closer and closer and closer and closer, you can move that point will be moving closer to that, and the h value will be moving closer to 0. But you'll see when we write down the formula, I just want you to understand that. So you'll see when we write down the formula how it looks like. Now, before we do that formula, let's look at the average gradient. If I'm given the equation f of x equals to x squared minus x minus 6, find the average gradient. In other words, when we talk about the gradient of a curve, we talk about the average gradient, right, between x equals to 1 and x equals to 3. So in other words, we are having a sketch, a parabola graph, and we have got a point x equals to 1 and x equals to 3. like the one that we were doing previously there. So how do I get the average gradient here? So my average gradient will be, so I'll take f of 3, which in this case was f of x plus 1, remember? Minus f of x plus h, minus f of 1. In this case, it is f of x. So all divided by the 3 minus the 1. So if you look at the one that I've done previously, it was f of x plus h minus f of x divided by x plus h, which is this one, minus 1. Right? Now, then I substitute. F of 3 means I must substitute the value of x by 3, like the one we have done previously. So I'm going to get 3 squared minus 3 minus 6. So I'm done substituting by f of 3. Then there's a minus sign. Then I'm going to substitute by 1. So I'm going to say 1 squared minus 1 minus 6. Then all this will be divided by 2. From 1 to 3, it's 2 units, right? So we said 3 minus 1. So I'll start with the bigger number. Please do not swap. It's like in this the gradient of the straight line. Don't swap them. Okay, if you swap the top one, swap the bottom one. So what I'm trying to say is that if I say f of 1 minus f of 3, there I must say 1 minus 3. So I can't say f of 3 minus f of 1, then at the bottom I say 1 minus 3. Then my answer will be completely wrong. So now you can use your calculators there. I think 3 squared, it's 9. 9 minus 3, it's 6. 6 minus 6 is 0. And 1 squared is 1. 1 minus 1 is 0. Minus 6 is a minus 6. But therefore, remember, then if it's minus 6 here, times the negative will give us a positive 6. All over 2. So my average gradient of that will be 3. So the average gradient there will be 3. So remember that formula is from the f of x plus h minus f of x, all divided by x plus h minus x. So I can write it like this. I know at the bottom there is going to give me an h, okay? Right, because there, if I substitute, if I work it out, I'll get f of x over that, and that will be divided by h. So that is the average gradient. Okay, right. And we know the h is the number between the 3 and the 1 in this case. It's a number between, the distance between 1 and 3. So from 1 to 3, we've got 2 units in between. Okay, let's tackle the other one. Determine the average gradient given the function minus 2x squared plus 2, where it is between those 2 points. So I know, same thing that I'm going to do, average gradient is going to be minus 2, first substitute by 2, plus 2, then I have that. Then from there I substitute by 0 squared plus 2. Then I'm going to divide everything there by 2 minus 0. Alright, so now I'm going to have, I'll work this one out. On the first one, I'm going to get a negative, this is going to be negative 2 times 2 squared is 4. 4 times that is negative 8. Then that is plus 2 minus, this is a 0. That whole thing is a 0. And then from there we have a plus 2, and then times that will be a negative 2. Right, all divided by 2, and that answer there will be a negative 4. So the average gradient of that, and these are exam questions, we get them in the exam, but I know some of you will prefer to do it this way. First, I've got an x equals to 0. So if I substitute this by 0, I'll get a 2. So my y will be a 2. Yes, it will be a 2. if I substitute that by 0. The other one, if I substitute by 2, my answer there is going to be a -6. Your y will be -6. Then from there you have got coordinates there, so your coordinates are 0 and 2, and the other coordinate is -6 and 2. Then you get the gradient of the line by using y2 minus y1 equals to over x2 minus x1. It's still the same things, but in this case we're just doing this so that I then explain how we get the first principle. Remember, in calculus we're just doing gradient. That's all that we're doing. The rate of change is gradient, so we're doing gradient. Now if we look at this now, deriving, to derive means we must get the gradient. So I need to find the gradient, but there are ways on how we do it. In technical maths, we're saying first principle, you must use first principle, and we state it that you don't have to use the rules. I'm just going to make a quick example in terms of why I say derivative, it's gradient. So if I take a question, for instance, y is equals to 2x plus 3. And we know the equation y equals to mx plus c. Now, if I say I want to find the gradient of that, so the gradient of that will be 2. That is the gradient of that. So when we do the rules, I'm going to come back here and show you that how do we get this number here using derivatives. So in this case we know, because it's there, it's written, the gradient is 2. Now when we talk first principle, this is what we're talking about. We're saying this thing there means if I take this x here and move it, remember this is x plus h. If I take this h here and move it closer and closer and closer and move it backwards, it will go closer and closer and closer to 0. Because if x is 0, then we got x plus h, which is a0. So that is why we say here we want to move the x to 0, so that we then get the average gradient of that line at a certain point. So we want to get it at a certain point. So this is the formula that we use when we want to find the gradient at a certain point. But with this case, we first have to do it using the first principles. All right? So in the first principle, this is the formula that we're going to use. If you see a question that says, derive the following using first principles, then you know that the formula that we need to use is the formula with the limit and the formula for the average gradient. So we're trying to move the h closer and closer to that particular point that we're looking for. Okay, right. Now, if we then look at this question here, the first principles. So that formula is there in the formula sheet, so you don't have to memorize it. It is there in the formula sheet. Now, in this activity, we are saying determine the derivative using first principles. You see, this is how they're going to ask you in the exam. F of x is equals to -5. So the first thing that you need to do, there are ways on how we write a derivative. So if I need a derivative, then I'd go for f prime x. I call it prime. So f, that dash there, x. So the f prime x, it's nothing else but derivative. So if you see something like that, you must know it's gradient. It has been derived. So we're getting the gradient. In this case here, now we know if I draw a line of -5, y equals to -5, it will be somewhere there. -5. This is the y axis, x axis. So now, if I draw this line, and with your knowledge of gradients, we know that the gradient of that line is 0. The slope of that graph is 0. So meaning that if I work out this one, I must also get a 0. But let's check. I'm going to do the limit of, so first we write down the formula of f of x all divided by h when h is approaching 0. right? I cannot substitute immediately by h by 0, okay, because then the whole thing becomes undefined. So then I'm going to have the limit of, now I'm going to substitute the value of x by 0 there. Can we see a 0 on that negative 5? The value of x there, there's no x there, so there's no x that is being attached. But yes, I can say that this thing here can be the same as negative 5 x to the power of 0. Now you know your exponents, you know. This x to the power of 0, it's nothing else but 1. So it will be the same as negative 5 times 1, which is going to be negative 5. So this is x to the power of 0 there, which we don't even write in mathematics. Now we're going to say, if there's nothing, if I substitute the value of x by x plus h, it will still be raised to the power 0, so it will still give me negative 5. So which means that that one will remain negative 5. Okay, so now, if it remains negative 5 minus f of x is negative 5. So this one I write it as it is because it is from my function. Divided by h when h approaches 0. So which means I'm going to get the limit of minus 5, negative is positive, so it will be negative 5 plus 5, and the answer will be 0 over h. And 0 over h is nothing else but a 0, meaning that f derivative of x is 0, and this is gradient. So the gradient is of the graph of negative 5, it's 0. So that's how we do it using the first principle. Interesting one on this one. So we have the negative 5, we know it's x to the power of 0. You substitute anything, you raise it to the power of 0, it's still going to give you 1, and the 1 multiplied by the number, it will give you that number again. Okay, right. Maybe let's look at the next one. Next one should be interesting. Yes. If I've got a graph y it's equals to 2x, what is the gradient of this graph? This is plus 0. What is the gradient of that graph? That graph gradient is 2. Can you see? The gradient is 2. Which means that in this graph, I must get 2 as my gradient, because the gradient of that graph will be 2. But let's see how we can get that gradient by using the first principles. So we're going to say f, again, that. I'm now going to write down the formula. Remember, you must always, for now, please, we want you to write down that formula, because you'll be practicing all over h when h is approaching 0. Okay, every time you must write down that limit until at the end when you don't have any value there. When you have all those things cancelling out, and then at the end when you have a number, then you can just do away with it. Or after you have substituted the value of h by 0, then you can be able to do that. Now in this case, let's move on. Limit. So wherever I see x, I substitute it by x plus h. So I'll have 2 into x plus h. Remember, I don't have any other thing there on my equation, so I'm done with that part. So I can just put it in the square brackets and say minus square bracket. What is f of x? It's nothing else but 2x. That whole thing there is divided by h when h is approaching 0. Now, never substitute by h here. So I'm going to have, you see, I'm always writing that until at the end when I can, I've simplified that. So I'm going to get 2x plus 2h minus 2x all over h. So I've multiplied this and that, then that one remains there. It's a negative, so it's a positive, then times negative, it's a negative. Then I'll have the limit. You see, I'm writing it again. So it's 2x minus 2x, it's 0. I'm left with 2h over h. The h and the h cancels out. Then is then that I can write down my answer here as how much? 2. And you see what I said about the gradient? The gradient is 2, and that we also get 2. I'm writing it like that here, so it is the gradient. So I got the gradient, it's 2, so I know that I am correct because the gradient of the straight line is nothing else but 2. Right. Okay. Playing right along. Now you have 2x minus 3. Same principle, y equals to 2x minus 3. What is the gradient of this graph? Y equals to mx plus c. The gradient of that graph is nothing else but 2. So the gradient there is 2. Let's see if we can do the same here. F at x, same thing. F prime x, it's equals to. Now I'm no longer going to write down the formula. We're used to that formula now. I'm not saying don't write it when you're writing your tests and your classworks. You must always keep writing that formula. Now I'm going to now quickly substitute 2, that will be x plus h, minus a 3. Don't forget the 3. Always, most of the time, with the learners, when they finish substituting by the x plus h, they forget the constant there. So it's minus f of x, it's 2x minus 3. And the whole thing is divided by h. What did I miss out now here? You see now, here, what did I miss out? The limit when h is approaching 0. That's very, very, very important. We must write it down. So therefore, it will be the limit when h is approaching 0 of 2x, right, plus 2h minus 3, negative times positive is negative 2x, negative times negative, it's positive 3, everything there divided by h. Then I simplify this. I think 2x and the minus 2x will be 0. Subtract. What else gives us 0 there? Minus 3 and plus 3 will also give us 0. What am I left with now? I'm left with 2h over h. When h is approaching 0, the h and the h cancels out. I'm left with that number. That number is now my gradient. Then I said the gradient of that line is 2. That is the gradient of that line is also 2. So that is how we calculate this by using the first principles. It's an easy question. The exam thing is about 5 marks in an exam, between 4 and 5 marks. Please, this question, it comes every year. We must be able to, every exam, in March it will be there, in June it will be there, in September it will be there, and end of the year you will have the same question. If you start practicing it now, you are guaranteed of the 4 or 5 marks at the end of the year. Right. Here is a one with a fraction and a pi and an x, and yeah, this one is a bit too much because then it has your 2 pi, you know, you've got your 1,5x, but there's nothing difficult in this question. We just need to do exactly what we have done in the other ones. So first of all, it's a g now, it's g prime x, it's equals to the limit of f of x plus h minus f at x all over h when h is approaching 0. So now we substitute. Remember, 2 pi is nothing else but a constant, because it's 2 multiplied by 3,14 and all the other decimals. So it's a constant. So we're used to working with this pi. Here it's where we need to substitute the value of x. So the first thing that we're going to do, we're going to say the limit of, then I'm going to write 2 pi, because there's nothing to substitute with here, plus 1,5, then I substitute by x plus h. Oh, now that looks simple. Then from there, minus f of x means I must repeat it as it is. All right, remember in this case it's going to be g of x, sorry, g of x. So now I'm going to say 2 pi plus 1,5 x, right, all divided by h when h is approaching 0. So here I'm now going to simplify the limit of 2 pi plus 1,5 x plus 1,5 h, because I'm multiplying this out, then my minus sign, 2 pi, negative by positive, it's negative 1,5x, all this all over h, when h is approaching 0. Then what do I see now? 2 pi and minus 2 pi is 0. 1,5x minus 1,5x is 0. What am I left with? Limit of 1,5h all over h when h is approaching 0. Once I cancel that, I'm left with 1,5, and 1,5 is my gradient. So my gradient g at x will be 1,5, and nothing else. That's a straight line with a 2 pi. So that gradient of that line will be 1,5. Okay, there was nothing difficult there. Sometimes we look at the question and say, but this question is too much. What am I going to do here? There's a lot of work that you need to do. I've never seen it in the exam. But that is how we can do that question. It's a very easy question. Right. Now, the last activity under this first principle, you see how many I've done now. Different kinds. So you also, when you're practicing, you must do all these questions like this. Okay. Now, given h of x equals to, now I've got a fraction. I know most of us as learners, we hate fractions, but that's an easy fraction. It's x over 2. As simple as that. Derive that. Determine the derivative of that using the first principles again. Now first I must write it nicely there. So I can say h of x, it's equals to. Now I know it's that, so there's a 1 here, 1x. So because I don't like it like this, I can write it like this, half of x. Because it's the same thing. So it's half x. Now it becomes easy. My gradient is a half. So I can be able to work out there. So now I'll go same thing, h prime x equals to the limit when h of x, what? H of x plus h minus h at x all over h when h is approaching 0. Don't confuse this h and that h. The other one is for the function and the other one is for the movement, that value of x. So now we're going to substitute. We're going to have the limit of half into x plus h, square brackets, minus h of x, which is going to be a half x all over h when h is approaching 0. So I'm going to have the limit of half x plus half h minus half of x all divided by h when h approaches 0. Easy again. This one and that one, they subtract each other. Then what am I going to get? The limit of half of h all over h when h is approaching 0, and once I cancel that, my answer is going to be a half, and that is my gradient. Easy stuff. That one was quite very easy. So we look at the first principle, 4 to 5 marks in the exam is the first question. I think it's question 6. Question 6, mostly the first question is at the end of the year. I'm talking the June and the end of the year. For now, March, look for this. If they say first principle, then you immediately go to your formula sheet and copy your formula as it is. Then substitute the x plus h on the x. Then you simplify and you get your full 4 marks or 5 marks depending on the question asked. Right. Now let's look at the rules of differentiation. Now once we have done with it, with the first principle, the next question there will be using the rules, the general rules of differentiation. Now we have got the rules, we no longer have a problem. There are many ways of writing that one. So that one, we've been using it now in the previous activities. Now there are other ones that are written like that. And we say this is the derivative of f of x, derivative of f of x with respect to x. This is very, 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 very important. Once they say with respect to, then you must look for the letter that is written there. Sometimes they say with respect to r, with respect to a. It means that you are differentiating the a. So please make sure that you check which letter is written there. Derivative of x over derivative of y over derivative of x. We say this is the derivative of y with respect to x. Can you see? It's dy over dx. Sometimes you might find dp over dr. So meaning that in your equation there will be p, there will be r in your equation. So you're differentiating r in that case. So please make sure you understand this one. Those two we say is the derivative of y or the derivative of f of x. Okay, so this one is for the f and that one will be for the y. Now let's look at the quick example here on the rules. I'm going to start with this rule before I come to the one with a constant. If f of x, you are given something like this. It's a number multiplied by the x with an n as an exponent. K is the constant, that's the number that I'm talking about. Then f, differentiation of x, what do? We take that number here, we put it there. Then the n that was there, we multiply it by that k. So in other words, can you see the n that was there? So we've multiplied it by k. Then on the n, on the exponent, we always subtract a 1. So we say minus 1. So that 1 will be the only number that we subtract there. We cannot subtract a 2 or a 3 or 4. We are only subtracting a 1 on that one. So if we look at the example, in the example, say determine the derivative of x. If f of x is given like that. So can you see this is more or less the same as the one that was given there. So what do? We take that number n, here is the n, which is a 2. We multiply it with a constant. So in other words, I'm going to multiply it with a 2. And I bring back the x now. Out of this 2, that number 2, I'm going to subtract a 1. So my answer will be 7 times 2 is 14. And then if I subtract a 1 from a 2, I get a 1. Okay, and that's how we use the rules to do the derivative. Remember, we started with the first principle. Just as another example. Remember the first one that we have done there was y equals to, if we say 2x for instance. Then they say determine the dy over dx. So I'll say dy over dx. Then I'll use the same method here. 1 times 2 is 2. Subtract a 1 here, you get x to the power 0. and x to the power 0 is 1. 1 times 2 is 2. So we are still doing the gradient in this case. So why? Now you're asking me, why are we using the first principles to derive if we can quickly use the rules, and the rules are like one step? There are questions based on the first principle. You must first understand the first principle, and there is a question based on that, so you must know that. But here, when we're using the rules, you are allowed to do that. You don't do the first principle when you are asked to do the rules. Okay, so that is a quick example that I wanted to do. Now, look at this one also. If f of x equals to k, k is a constant. Now, this is a constant. Then they say the f of x will be 0. There's nothing to think about here. As long as the number that is given there is a constant without an x, without any other value, so therefore the derivative of g will always be equals to 0. So meaning that even if I'm given g of x equals to 2 pi, my g of x will always be equals to 0. Because this is as long as there's no x here, therefore my gradient will always be equals to 0. And as I did with the other one, that the graph of y equals to 7, the gradient of that line will always be equals to 0. Any other line there, the gradient will always be equals to 0. Right? So when it's a constant, you don't have to work it out, just put a 0. But if I can just quickly share with you this. If I've got g to the power of x equals to 7, that 7 is x to the power of 0. It's 7x to the power of 0. Which means if I use that method that I've done in the previous example, 0 times 7 is going to be 0. X to the power 0 minus 1. Therefore, it will be 0 into that. Anything multiplied by 0 will give us a 0. Okay, so the answer will be 0. So you don't have to work it out. Just write a 0. If you see a constant and they say use the rules, you see a constant, you write a 0. Okay, right. Let's look at where we have a binomial in this case. That term here and this term there. Right, so now how am I going to do the dy over dx? So the dy over dx is the same thing. So if I'm given a y, then I'm getting a dy over dx. Then it will be dy over dx. Once I write dy over dx, then I must first derive it. So I'll say 3 times 6, it's 18. 3 minus 1, it's 2. I'm done with the first one. So meaning that I can do this one and that one separately. So I'll then go to plus sign. Right. Then I see I have a negative. Then I must just put a bracket quickly. If I see a negative on the exponent, on the x there, negative exponent, then I put a bracket. Then I'll say minus 3 times this, it's going to be negative 3 x to the power. If I subtract 1 there, what do I get? Negative 4. So my final answer will be 18x squared, negative times positive, negative 3x to the power of negative 4. Don't forget to change that sign. It's very, very, very important. That's why I've done it like this, so that then you know that that sign must change. Anyway, it's going to be negative 3 times positive 1, which is negative. So you should have seen that. Please, 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 please do not derive one part, like for instance, derive this one and leave out the other one. If you derive the whole thing there. Okay. All right. Now, here's another derivative. In this case, determine dA over dr. Can you see now? We're no longer talking dy over dx, because our formula there is a equals to pi r. That a here on top there is your y value. Can you see? Then we've got the dr, which is our x. But in this case, it's a equals to 2 by pi r squared, which is the area of the circle. So now, how do I do that? So for me to find a dA over dr, it means this is what I must do. So the r is the one with an exponent that I must derive. So now I'm going to have 2 multiplied by 1 here, or by pi. So it's going to be 2 pi. Then I subtract a 1 on the r. Because I'm deriving r, so it will be r to the power of 1. And if you can see this, nice. When I derive area of a circle, then I get the circumference, the formula for the circumference. Beautiful. Now, in the second one, it also looks very crazy because it's got a square, it's got a square root, and for me, a minus b all squared, it's not equals to a squared minus b squared. I can't say this squared and that one squared and I'm done. That will be incorrect. So first of all, I cannot derive here before I simplify it. So first I must do what? I must simplify. Right? So how am I going to simplify this? So I'm going to say, before I derive, you see I'm writing it down. Before I derive, I must simplify it. In other words, I must have x minus square root of x multiplied by x minus square root of x. So I must split this because it's squared, so it's 2 of them. Then I'm still simplifying. That's why I'm keeping my dx. X times x is x squared. X times this is negative x times square root of x. Then this one times that is still the same thing, negative x square root of x. If I've got this, I have 2x square root of x. So in other words, I'm adding x root x minus, I'm adding them with a negative sign. So my answer there will be negative 2x root x. Then from there, negative root x times negative root x will give me an x. But still I have not differentiated, so I'm still simplifying. What am I simplifying now? This square root here, I must change it. So I'm just going to put it here. I'll put it just on top there. So 2x root x. So I know root x here can be changed to what? To 2x times x to the power of half. You have done exponents. So that square root will be a half. So it's a 1 here. So the bases are the same. What do we do with the exponents? We add them. So the answer that we're going to get is 2x. 1 plus a half, it's 3 over 2. So it means that I must get x squared minus 2x, 3 over 2, plus x, then I'm done. Now I can now differentiate. You see now I haven't differentiated. What was I doing here? I was simplifying. Right? I was simplifying there. Right? So now I can differentiate. Once I start differentiating, I no longer put this. I put equal sign. Because I'm differentiating now. So I'll have 2 times 1, it's 2x to the power of 1. I've subtracted 1 there. 3 over 2 times 2. So if you have 3 over 2, you're multiplying by 2. You'll get a 3. So I'll get a negative 3x. 3 over 2 minus a half, minus 1 will give us a half. Then that one is 1. So I'm going to give a 1 here. Right? So because if I take 1 times 1, it's 1. 1 minus 1 is 0. X to the power 0 is 1 times 1. So this is my derivative. So that's how I do the derivative. This question is about 5 marks to do that. So meaning that you have to really practice more of these questions, because the whole question there, you already have 5, so you can have your 5 or 7 marks if you are given the 2 of them. Okay. All right. Now, that next activity, we are still deriving. dy over dx, it's that. So now, how am I going to start? Where am I going to start here? Can I start by deriving? No problem. Here, straightforward, I can just derive. So I need to get dy over dx. No need to simplify anything here, because I can quickly say minus 5 times this, it's going to be a positive 5. If I subtract 1 here, I'm going to get a negative 6. So already I've derived that one. Okay, so minus 5 times negative 1 will give us a positive 5. Subtract 1 there, you get negative 6. 4 times 3, it's 12. So it's going to be a plus 12x. Subtract 1 there, you're going to get a 3. So my final answer is that. So that's a simple 2 marks on this question. All right. Now, here is a busy one. This one is a bit busy. Now, how am I going to derive this? So I need f prime x. Before I can do that, I must simplify this. I cannot derive it in that form. So, which means I'm going to write f of x. You see, I'm not writing f derivative of x. I'm writing f of x because I must first simplify this. In exponents, if you don't know your exponents in these questions, you're going to struggle. So the first thing that you need to do is to practice your exponents. X to the power 4, taking it up there, will give me 3x to the power negative 4. You know the rule? If I've got 1 over a to the power m, that gives me a to the power negative m. That's the rule that we are applying there. Right, so now with this one, same thing. That I can say, I'm going to work it out here now. I'm going to say x to the power 1 divided by x to the power of half. The bases are the same, so we just subtract the exponent. So we're going to have x to the power 1 minus a half, and that will give me x to the power half. So instead of writing this, I'm going to write minus x to the power of half. All right. Now, working it out now, can I now derive? Yes, now I can derive. Then I'm writing f prime x, it's equals to. Okay, so I must first simplify before I derive. If there's, you see in this one, there's no simplification to be done. But there, I have an x to the power 4 there, the denominator. Cannot derive, I must take it up there. So let me derive now. Negative 4 times that will give us a negative 12x to the power negative 5. Because that part here, we are multiplying, and then the minus 1 there gives us minus 5. Then here, what am I going to get? Half times 1 will give us negative half, times negative half, sorry. Then x here, and half minus 1 will give us a negative half. So we must write, and this is the final, and you can write that one as a final answer. Unless if you are given, write it in positive exponents, which most of the time, I don't see that question being asked like that. Okay, but if it's written, it's asked like that, you revert back to this law, because you've got a negative exponent, so you revert back to that law. All right. Okay, so that was quite an easy question. All right, now here is another challenge where we see learners doing a lot of mistakes. First of all, that we cannot differentiate when we have a denominator in there. We cannot differentiate. So what should we do here first? We need to first simplify. Now in this case, the easy way, there's easy way out here, I can see, because I can see that what is on top there can be factorized. So, but mostly you find that what is written at the bottom, it's one of the factors, because it must cancel out. So x plus 3, the other factor will be x and 2. Then I'll have x plus 3. Now, the plus 3 must multiply with a negative 2 to give us a negative 6. Okay, done. Now I can see now that and that can cancel out. So I'll have the x into x minus 2. Then to differentiate that is very easy. Then I can say, what is the differentiation of x? It's 1. The differentiation of a constant is 0. So I don't have to write 1 plus 0. So my final answer will be a simple 1. All right. Okay, so that one was also very straightforward. But now you must know, when I have the numerator on top, and then I've got a numerator and a denominator, I first see if the top one can be factorized and can cancel out the bottom one. There are questions where you might get something like this. Let me just put this one, where you can get maybe y is equals to x cubed plus 2x squared plus x all over x. See, in that case, we're having a numerator there and a denominator. What do we need to do? Simplify first, because you cannot derive and say 3 times 1 and then from there 2 times 2 and then that, and you derive that one to be 1. That will not work. So what you need to do is you have to then divide all this, or sometimes they put a square root on there. So you first need to do what? Divide all of them. X cubed over x plus 2x squared over x plus x over x. Then you can then simplify that, and then you can then derive. Then you are going to have your x squared plus 2x plus 1. Then you can derive this. But without doing this, then it will be very difficult for you to derive, because that answer that you're going to get, as I said, it will be very much incorrect. So you must derive correctly. Okay. Before we do this one, we're going to take a 2 minutes break. Then we will be back in 2 minutes. Okay, welcome back. D, we need to determine dy over dx if 2x squared plus y equals to 5. So here in this case, the y is not on its own. which means I must first make y the subject of the formula so that I can do dy over dx. Okay, so the y which is on top is the one that must be the subject of the formula. So which means I must then first write 2x squared y equals to 5 and then divide everything there by 2x squared. All right, then I'm going to get y equals to 5 over 2 x to the power minus 2. Now I've done that. Now you're asking, why are you writing it as minus 2? Because it was that. So if I've got, for instance, 2 over x squared, for instance, that will be the same as 2, or let me say 2 over 3 x squared. That will be the same as 2 over 3. The x squared must go up there and become x to the power minus 2. So that's exactly what I've done. We have 5 over 2x squared. Now I've left out the 2 at the bottom, but the x squared gone up there to make it x to the power minus 2. Remember, if I've got a half, 1 over 2x, this is not the same as 1 over 2x, right? This is not the same as that. So if I've got 1 over 2x, this is the same as x over 2. Remember, I've done it in earlier question. So which means that if I've got 1 over 2x, I can then take the x up, then it becomes x to the power minus 1. So that's what I've done there. So then I can derive, then it will be negative 2 multiplied by 5 over 2, which will give me negative 5, and the x, then that will be a negative 3. So I'll get negative 5x to the power of 3. Then in this case here, what am I supposed to do? I'm going to write dy over dx. Can you see here I only wrote y? What is the reason? It is because that thing here is not yet derived. Once I start deriving, then I put dy over dx. In this case, once I start that thing, I write equal sign. Don't write dx again. Just write an equal sign to show that now I have derived. Right. Right, let's look at the next question. Or before we do the next question, can you take a 1-minute break?
Do you know that you are different? Do you know that your fingerprint is different? It's different from your peers, from the people that you are studying with. So do not compare yourself with your peers. Do not compare your results with what they're getting, because you are different. You have your own talents and skills, and also you have your own gifts. Embrace what you can do. Always put in the work to make sure that your results become better than what they were yesterday. But do not compare yourself, because when you compare yourself, you do not know what another person has, and they do not have what you have. So believe in yourself. You are different, and keep on putting the work.
Okay, welcome back. Right, now the next part of the work is the equation of the tangent. First of all, we must know what a tangent is. Now, we've been doing this even in grade 11. We know now what a tangent is. In these questions, we are now looking at the equation of the tangent, a tangent to the curve. If I've got, for instance, a parabola graph, and I've got a tangent, that graph, that line that touches that graph at only one point. So this is exactly what we're looking for. So remember, we only have 1 point. So, and then we, obviously, if I've got 1 point, what do I need? I need the gradient. So if I've got a gradient and a point, I'm able to write down the equation of the tangent. Okay. But in this case, they're telling us that the equation of the tangent is f of x, it's equals to mx plus c. That is the equation of the tangent to this curve here. And they say that equation is perpendicular to the line this. You see, there's so many things here. The equation of the tangent is given, the curve is given, and there's a line again which is perpendicular to that. So they want us to calculate the value of m, the gradient. But what do I know? This equation of the tangent is a straight line, right? This one is a straight line, and we're saying they are perpendicular. There's the key word here. So if the lines are perpendicular, what do I know? The gradient of line 1 times the gradient of line 2 must give us -1. But I have got the gradient of one line here, which is 1/9. So which means I can then write that one as 1/9 times the gradient of line 2 must give us -1. So for me to get the gradient of line 2, which is in this case the m here, it will be, I can multiply this one by 9 on both sides, multiply it by 9, so my gradient this side will be -9. Therefore, my m will be equals to -9. So if they said the lines were parallel, therefore the gradient of the line 1 will be the same as the gradient of line 2. So in this case, they're saying they are perpendicular. Know this. See, it's very, very important that we understand that part. Right. Same question here, but say, hence, determine the coordinates of the point of contact. Remember, if I've got that graph here, I think it will look like this. And now they want us to get the point of contact of that line. We don't know if that line goes that way or it goes that way, but we need the points of contact where the tangent is touching the graph. Where will that be? And how am I going to get it? Now remember, for me to get the point of contact here, at that point here, right, I need to derive this thing here. Because at the point of contact here, the gradient of this one will be the same as the gradient of that. So for me to write that, I'll have to say the gradient of this graph will be equals to -9. Right? Now, because the m is -9. So to find the gradient of that, what do I do here? I must derive. So I'll have 2x plus 3 equals to -9. 2 times 1 is 2, then you subtract 1 there. 1 times 3 is 3, then you subtract 1 there. The derivative of a constant is 0. Then this is what I get. So how am I going to get the value of x here? So I'll say 2x is equals to -12. Then the x value will be equals to -6. This is the x value. This is where the curve and the graph touch at that point x equals to 6. But we need a point, for instance. We need a point. So this is just the x value where it touches at that particular point. So if I need the point, I need the x value and the y value. So for me to get a y value, I must take this and substitute it into the original equation. I cannot substitute it anywhere, I must substitute it in the original equation. That equation, we used it to get the gradient of that. So we're done with that. So therefore I'll say y will be equals to -6 squared plus 3 into -6 minus 2. See, I'm substituting into the original one. So that will be 36 minus 18 minus 2. So that will be 36 minus 18 will be 30. It will be 18. 18 minus 2 will be 16. Positive 16. So that value will be 16. So this is the coordinates of the point of contact. So it will be 6 and 16. So probably -6, so it will be probably somewhere there. You know, the tangent will be somewhere there at 16, positive 16, and then -6 on the other side. So it might be somewhere there. Okay, which will make sense. So it means that the other graph will be this side because that must be perpendicular to that. All right, not knowing whether it will be a tangent or not. Right. So now, in this activity here, it's basically the same things. Getting the equation of the tangent. In this one, we're getting the equation of the tangent. In the other one, we were not getting the equation of the tangent. We were just doing getting the value of m, which is the gradient, and also getting the point of contact of that graph. So in this one, we need to get the equation of the tangent. But before you get the equation of the tangent, they might have asked the question directly and say, given g of x equals to 3x squared plus 9, determine the equation of the tangent at x equals to -3. But this question, they've given you sub-questions that can help you to get to the gradient, to the equation of the tangent. The first question they're asking you is to determine g, the derivative of g. So how do I get the derivative of g? So I'll go derivative of g. I don't need to simplify it now because it's simplified. 3 times 2, it's 6. Minus 1, it's x to the power of 1. 1 times 9, it's plus 9. X to the power 0 is 1. So I'll get this. So that is my answer. Right? Now, that next question says, determine the gradient of the tangent to the curve of G, where x is equals to 3. So in other words, we need the gradient at a point, at a desired point, and that desired point is x equals to -3. So in other words, what they want you to do is not to substitute the -3 into that equation, because then you're getting the y value. Now we want you to get the gradient. So remember, once I derive, what do I get? Gradient, right? So here I'm looking for the gradient at a point. So meaning that I must use this formula here, right? I mean the derivative that I got there, because this is nothing else but gradient. So at this point x equals to 3 means that my input, it's -3. So it means that I'm going to get a -3 plus 9. So I'm going to get -18 plus 9. So my answer there will be -9. What is that -9? Is the gradient at a particular point. Remember, this is a gradient. This is a gradient where there's no point, okay, because the x value is not substituted by anything. Once I substitute it, so it will be gradient at a point. So my gradient at a point will be -9. So obviously I can be able to get I need a point now for me to get the equation. And they say, hence determine the equation of the tangent to the curve where x is equals to -3. So first of all, what should I do? I have the gradient. The gradient I have, it's -9. The x value I have, it's -3. One thing that I need now is to get the point. Remember to get the equation of the straight line. Remember the equation of the straight line is y minus y1 equals to m into x minus x1. Right, I prefer this for this one because it gets you straight to the equation. Rather than y equals to mx plus c, you still need to calculate the value of c, then from there, then substitute it. Some of you forget to substitute, but once I do it with this one, straightforward. Now I have m equals to -9, x is -3. I do not have a point. I only have one coordinate, which is x equals to -3. I need the other one. So what should I do? For me to get the other coordinate, I must substitute the value of x by -3 into the original. So I'll have 3 into -3 squared plus 9 into -3. Then I'll get a value there. So what am I going to get there? I think I'm going to get a 0 there. So because that negative is 9, 9 times 3 is 27. And then 9 times this is -27, and I'll get a 0. So I've got a point here, -3 and 0. So if I've got -3 and 0, how am I going to get the equation? Y minus y1 equals to m into x minus x1. Now I'm determining the equation of the tangent. Remember, a tangent is a straight line. So I need the equation of the straight line. So this is my x1, this is my y1, and that is my gradient here. So I'm substituting now. Y minus y1 is 0. My gradient is -9. My x1 is -3. Then from there I'll have y minus 0 is y, then -9 x, then negative times negative is positive, positive times negative, the -9 will be -27. So that is the equation of the tangent. So the equation of the tangent, it's the equation of the straight line, because the tangent is the straight line. So meaning that if I've got that graph here, the line, the tangent, which is going to pass at -3 and 0, that equation of that tangent will be -9x minus 27. And you can do that by drawing the graph also, to say, you can draw the graph of 3x squared plus 9x, right? Then once you have drawn that graph, and then from there you input the point -3 and 0 on your graph, then you draw the tangent that passes through that line. I think that line will be a negative, because this graph here, so the x value, so that graph obviously is going to be turning at -3, I think -3 and 3, so minus b over 2a, so there will be 9, negative 9 over 2 into 3, and then there will be 9 over 2, negative 9 over 6, sorry, which is negative 3 over 2. So that graph is going to be turning somewhere here, and then it's facing upwards, and then from there we have that graph like that at 0. Sorry, the y-intercept there should be 0, sorry. And at another point, so the y-intercept there is going to be at 0, so the graph might be turning somewhere there. And then from there, you have the equation of the tangent at -3 and 0, maybe somewhere there. So that graph will be something like that. So that then you have a picture of what we are talking about. Okay, right, so all those things that I've said at the beginning in terms of what we're supposed to know, in this section, we're supposed to know the first principle, we're supposed to know the rules and the equation of the tangent to a curve. Only to a tangent to the curve, that is what they said on that. Okay, on that. So if you've got a curve, then you need the equation of the tangent. First derive the equation and get the gradient at a point. Then from there get the x and the y values. The x will be given. Get the y value. Once you get the y value, you have got a point and a gradient. Then you are supposed you just substitute those two into that formula here. Then you are able to get to the equation. Let me take this opportunity to thank you for watching, and please keep on practicing this section. This section, question 6, has got 20 marks, and you must be able to get all the 20 marks. Thank you so much.